All right, I think we're ready for the next session. If I could have everyone take their seats. Just go ahead and start. So our next speaker is Captain Will Shepard. Captain Shepard is a retired Navy SEAL, NASA astronaut, and SERC advisory board member. He served as a platoon commander and operations officer in SEAL teams on both coasts. Captain Shepard retired from active duty with the Navy and was USS SOCOM's science advisor from 2008 to 2011, where he managed the Special Operations Forces science and technology portfolio. Bill, go ahead.
Thank you. And I've got to commend the SERC for finding the smallest screen in the building for these slides. I've made them, I think, readable, but I'd recommend if people really want to see what I've got on the screen, come on up toward the front. There's no shortage of spare seats. This is going to be an overview of SERC's Capstone. And if I can. What do I hit to make this advance?
Go right.
Okay. So as you probably know, anybody that's a party to the SERC, we have a collaborative network of a little over 20 universities around the country. However, capstones are not limited to this cohort. We've got authority under the Department of Defense to work with any accredited university.
I'm videos. I'm just trying to make sure the video. Sorry.
Okay.
I have no idea what's going on. All right, there we go.
And so looking at that, these are the outside capstone schools that we have done work with. These are not part of the SERC consortium, but we do capstone work with them. Okay, so part of SERC strategy, we have 4 main themes, but the capstones are really focused on the bottom of the green arc of the circle there, human capital development. And this is one of the more interesting parts of my association with SERC. We've had discussions going back quite some time. SERC is mostly grants and research work for grad students, but the Capstone Marketplace is really the only thing that addresses the undergraduates. And we like to work with students who are not necessarily going to be system engineers. And the thinking there is that although the world probably doesn't need a whole bunch more system engineers, it does need a whole bunch more engineers who know something about system engineering. So that's been our theme for the several years that I've been working on this. For educators who know capstones, we have some differences in how the SERC runs the SERC capstones. We like to flip the classroom. We have students who go on our website, capstonemarketplace.org. They look at the research topics. They give us an idea of their interest in capturing that for their capstones during their senior design classes. And we just ask that they get some institutional support from a professor or a faculty advisor, and they give us a very short proposal and off we go. We do introduce into the capstone environment what we consider to be common business practices. We do resource the capstone teams. These are not grants. We execute subcontracts from Stevens Institute to each university, and these are fixed price commercial contracts. And we have milestone deliverables and invoicing just like you do in the business world. We have fairly strict review sessions. We do 4 a year, much like a venture capital company would look at the progress of the people they've invested in to do periodic reviews of their investments. We don't have a lot of industry participation at the moment. We have got a little bit, but we're trying to encourage more collaboration where the universities would go out to various companies that they know about and attract their participation in a particular capstone project. One thing that we can't really do as a UARC, University Affiliated Research Center, we cannot pay industry directly without a pretty strict contracting process, which is quite cumbersome. So we try and encourage the universities to do that on their own. And they're fairly unrestricted about how they can do that, except that they can't pass our SERC money to that company. But they can exchange services and materials and all kinds of things. At the end of the 2-semester design project that the students execute, we require tangible deliverables. Our SERC capstones are not about studies or papers. We have those, but at the end of the year, we have to have demonstrable prototype hardware and software, and we usually end up having demonstrations with our customers. So who are the customers? Right now, we're focused on the military special operations community. That's kind of my background. So I have used a lot of my Rolodex to touch base with most of the people here on the chart here. Special Operations Command, which is the headquarters in Tampa, the Naval Special Warfare Group, and a SEAL delivery team in Norfolk, Virginia area, the Army at Fort Bragg, and a new participant this year in our SERC capstones, the Special Operations Support Activity in Lexington, Kentucky. This is the warehouse that maintains, basically handles all the material that the Special Operations Forces use. We had a forum here a year ago in Washington. We were trying to get to the topic of how does Special Operations do logistics in really extreme situations. They're out in the middle of nowhere. They don't have a lot of logistics support. They might not be able to fly airplanes and helicopters around because the airspace is contested. So how do you do logistics when that happens? In overview, this SOFSA activity handles several different kinds of aircraft, ground vehicles, boats, electronics, lots of support. They have just warehouse, big complex, a former Army logistics hub in Kentucky, and they have warehouses that are just full of stuff out there that's moving all the time in to be repaired and back out to be issued to troops. So in this forum a year ago, we invited NASA to come in and to see if there was synergy with some of the support activities, logistics needs for what NASA is thinking about doing on the lunar surface or in their moon expeditions. And it turns out there's a fair amount of overlap. NASA is looking at closing the environmental loops so that you can reduce your consumables, your oxygen, your food, your water, digging up lunar regolith and making stuff out of it like rocket fuel, and getting a way to have megawatts of power on the lunar surface. And a lot of interest in telemedicine and advanced robotics. All these things will play in a future DoD force. And so we're trying to set the idea that we can develop and test these technologies now with university work. And it's getting some serious consideration from NASA. Just a quick overview, some of the more successful recent capstones. 2 years ago, we started a project at the University of Alabama, Huntsville. They knocked it out of the park. This is a view of a stowage module inside a small submersible. The problem was the Navy has these submersibles with people in them, but they have no space for their combat gear, their diving equipment, anything else that they're carrying on their mission. And everything's just piled in a big clump on the deck of the submarine. And so Huntsville came up with a really good design for this stowage module. And the Navy has taken this, and they are building and installing this module right now in an operational vehicle. So it's transition. Another one that is very high on my list, University of Texas at Austin has been working for 3 years on a self-intubating device that'll be used for a wounded soldier who has their airway compromised. And this device will be something that can be put over the mouth of the patient, and the medic or the operator will press the button and the device will automatically intubate the victim. And we're about a TRL level 4.5 to 5 now. The packaging is not what we want. So we're doing one more year of this project at Austin to try and get this to a form that looks to be something that people would want to use. The basic technologies of the device, finding the airway, moving the tube down the throat, positioning the mask and everything, that's all solved. As a matter of fact, the students use missile guidance algorithms and a CO2 sensor of not only use in the DoD, but maybe a commercial transition to ambulances and other people who are first responders. Okay, so Capstone universities this year. Except for the top school there, the rest of them are the usual suspects. Michigan Tech, Stevens, University of Massachusetts, Boston, Naval Academy, South Alabama, Austin, and Virginia Tech. We've added George Mason this year. They're doing a couple different projects for us. Real quickly, an overview of what these projects are. These are all topics that this logistics center nominated. The top ones in bold are the ones that we've locked down. The 4 at the bottom but first one is batteries that you can, lithium batteries you can put on cargo planes, and whatever happens to the battery, it's not going to be a hazard to the plane. The military really needs this right now. GMU is working on how to take a warehouse out in Kentucky that looks like the place that they stored the Ark from Raiders of the Lost Ark and make that more efficient. The rest of them are the near net rapid prototyping in metals. We think we're going to get that maybe at North Carolina State. They've got an excellent materials processing group down there, and we're trying to get them interested in doing that. Other topics, these are for the Army down at Fort Bragg. MT was working on various biometric sensors that trainees can wear as they're going through very aggressive training for courses like Special Forces, where they have trainees that are subject to hypothermia and all kinds of different physiological stresses. The instructors want these measurements so they know when a student's getting ready to go down, they can intervene and basically save that trainee from getting injured. We talked about the intubation device. Austin is working on a device that will allow, they'll basically inhibit when blood transfusions take place. We usually have to match the blood type. We're looking for a way where we don't have to do that. Anybody in the battlefield their blood can be put into somebody else to restore their fluid volume. And these are kind of crisis interventions on the battlefield before that individual gets to definitive care. But if it allows them to get to a care facility or a hospital, we can deal with the blood rejection later. We're working with technology to make working dogs more useful. Another one, we're checking how to detect in foreign languages the use of emojis and what the emojis are meaning. What's the sense of that emoji in the text. Are we having technical difficulties? Oh, doop, 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 doop. Houston, we have a problem. Okay. We just crashed the space shuttle. Sorry. Okay, Army Special Ops, identifying a couple different phenomenologies to identify friendly forces so that the good guys aren't shooting at the good guys. Pushing videos from drones through the cell phone network. Two at the bottom I really like. One is a hasty way to use a drone to get mapping of a specific area right now and to do coherent change detection. The drone flew over that parking lot yesterday. It looked like this. It just flew over the parking lot this afternoon. What's different? University of Massachusetts Boston is working on that one. And last one is celestial positioning accuracy. This is going to be a testing program for a very small micro star tracker. And it'll be used hopefully on vehicles and boats as a way to navigate when you don't have GPS available. Naval Special Warfare. These are mostly tied in with the Navy's dry submarine. We've got a simulator that we're building, a tablet that's kind of like a flight ops manual, and looking at human performance. How do CERC capstones help the government? We think it's a way to stimulate innovation in the government organization. We generally go to very low levels of operational units, and we ask the senior NCOs and the junior officers, what do you need that you don't have? What do you want that nobody's going to give you? And we turn that into student projects. We think this is harvesting the intellectual capital of the force, and the ideas that come out of the students are generally pretty innovative and out of the box, and we like that. We do tend to cultivate in these military units people who are really the unit's MacGyvers, and it allows a particular organization in the DoD or the military to increase the bandwidth of their R&D effort. For not a lot of money, they can even look at their formal research and development projects that are being done by industry. They can turn students loose on a competing analysis of what's going on and get very smart about the value that they're getting from industry on a particular effort. The CERC capstones are very low cost. Our average spend is between $4,000 and $5,000 per project for 2 semesters worth of work. And hopefully gives students a lot of exposure to what kinds of things they can do in the government as engineers or members of various organizations. And hopefully it will stimulate their interest in future employment. So quickly, if you wanted to learn more, we have a website up, the capstonemarketplace.org. And you can email us at the Capstone Marketplace at Stevens. And I've got my names and Mike DeLorme, who assists me in managing this, on the screen as well. And are we going to have this presentation available online after the fact? So if you didn't get all the detail, you can get a copy of this online after we're all done. And I think we are through. Questions? Okay. Way in the back. Dan.
So, given some of the other things we've talked about in this session, do you have any sort of episodes or evidence of kind of as you interact with these students and watch them go through? Obviously, they're pretty close to being finished with a degree, but any reflections on what we talked about earlier and how?
Yeah, more than you want to know, probably.
Any reflections?
Well, we get time, right? My impression is the following. Students don't get, first of all, most of these students they're all basically in some sort of engineering department. We have a couple students that come in once in a while who are business majors, which is good because when we put them on the team, We want them to track the schedule and the finances and the contracting and all that, doing the business stuff. But the kids in general are not super prepared to do business kind of stuff. Having them stand up and make a presentation, it can be very painful. And not that they, part of our method is to basically teach them how to make a good, concise presentation. And this is something that they don't get in their engineering world. Not everybody has exposure to things like a work breakdown structure, a Gantt chart. Few of them know anything about what a contract is. Deliverables they get, but being able to stand up and basically say what their path is to develop something is something that they don't have much practice in. And they say, well, we just did it this way. And I go, well, why did you decide that technical path over these three other alternatives? And they kind of struggle with that. And then they say, well, we did this because we like it. And I said, that's not going to fly in the business world. You have to be able to justify in some quantitative measure why that path is the right one. And it could be complexity, money, time, whatever, but you can't just say, well, this is what we wanted to do. And so students tend to do what they like doing, and you can't, it's hard to get them out of that mold. I could go on, but I think when they're prodded to do it, they can be very good at conceptualization, coming up with three things that, I wouldn't think of, or anybody over 40 would envision. But I think, and the other thing that I find is kind of difficult is the students are all about learning new things, but it's very difficult in the institution to get the institution to step up to a multi-domain or a multidiscipline project. The mechanical engineers don't like to do stuff that's got a lot of electronics or computer stuff in it, and vice versa. And this is a problem with the relationship with SERC and the university faculty. They often don't give the kids the depth that they need to solve some of these. I wouldn't say the problems are necessarily super complex, but they're broad-based. And so you need some computer talent, you need some metal bending, you need some analytics. And quite often, that's the weak part of the team, is being able to assemble enough students and then faculty help to bring that skill to the problem. Does that help?
Yeah, that's helpful. I was wondering, and kind of answered what I'll ask it, if you had at least one or two successes of feeding back that insight back to a particular university and that they got better.
I won't name the school because it's a negative, but one school said, this is too much for us. We don't want to do anymore. The overhead we're about teaching, mechanical / industrial engineering. We're not about doing what you envision. So we're going to, we'll see you later. And I'm very unhappy about that, but that's life. We can't please everybody, and we're not here to please everybody, but we're on a mission to train people who walk out the door as graduates who are useful in basically an industrial environment. They can weigh into a project and make some contribution. Other questions? Wow. Okay. I think we're ready for a lunch break. Thank you now.
Thank you all for your participation today. I think we're going to break for lunch, and we hope you join us later this afternoon in this track. Thank you.